Hey everyone, welcome to the November community meeting. Just a reminder, this happens at the first Monday of every month. So you're at the right place. Okay, let's go ahead and jump right in. So this is the agenda for today, and just some reminders. So the 9 a.m. Pacific community meeting is this one, and then other Mondays we have our developer hour, which is mostly for technical discussions. It's not recorded, and there's no like formal agenda usually, and we usually it's sort of people coming asking questions about the design of things or just general directional questions. Every Thursday we have Ramiro is hosting the op office hours for people who are implementing ops. And we have our chat, which is really active on Discord, and we have our forum, which is less active. So here's the statistics for the last month. Things that were a little bit quieter than the previous 2 months, because I think a lot of the MHLO work has sort of been quote unquote completed. So there's not as much activity on that front. But still very strong participation. So let's jump right in. Okay, Anush, do you want to talk about the stable diffusion stuff?
Yeah. So I think we mentioned this briefly a couple weeks or months ago. We had been working on it. We have been working on various diffusion models, and we got vDiffusion working first. Stable diffusion now, but in the past few weeks we kind of had it running end-to-end on a just released GPU architecture, just going to show it can we can kind of target SOTA hardware with SOTA models using Torch-MLIR, and obviously ERI code gen and nodes tuning. But yeah, this is super exciting, and it's all open source, so feel free to check out Shark and try it. You can run it with any backend. It's not limited to any particular CPU or GPU. We are slowly testing various combinations of backends, Vulkan, CUDA, ROCm, level 0. But the goal is to have a single place that anyone can come try out stable diffusion that's going through Torch-MLIR and ERI. Yeah, and we're looking at newer models like follow on to like stable diffusion kind of things. So as they become available, we'll kind of make them public and it'll be here. But yeah, it's just exciting to see it all running and in like very fast times.
Yeah. Awesome. And I can actually attest when Anush says, oh, it's open source, sometimes it's like, oh, there's some pieces scattered around, but like it really is just like you run a script and then, call Python on the web server that runs this website, and then it will, it'll, render the images for you right there, and then you just like add a button. It's awesome.
And the MD logo is in a separate branch. So the main branch, you won't get that. So feel free to try out main branch so you can use it for your own thing. But we're happy to add, partner with anyone if they need any specific models or enablement. We are doing stable diffusion training and all through Torch-MLIR and on large scale clusters. So if those kind of things become interesting, please reach out. We're happy to help. But those are things that we see in the next few months, etc.
Suraj?
Hey, I'm really impressed with this new work that the Node folks have done. And in a few other similar contexts, we may be trying to bring up a significant workload, which may or may not be public, but we would be very interested in knowing what are the kind of pitfalls or challenges you faced in bringing something up like this quickly, and a general document. You don't have to go into the details that are secret. Describing what are the things you faced and how you overcame them might be very helpful. How you quickly connect things together, because there's the Torch-MLIR piece and probably the URI backend piece and anything else.
Yeah. So I think the way our team kind of approaches it is like we kind of split it into different pieces. We look at state of art of like all compiler technologies. Like if you look at AI template for now, it has a quick way. It bypasses Torch NN frontend. It has its own NN frontend, but calls Cutlass, and it calls like in a native memory format, etc. So we want to have similar shortcuts. So initially we had similar shortcuts that we had to do with PyTorch, but then eventually we snuck that into Erie in the layer down at the codegen layer to do like just transposes and amortize that way later in the pipeline.
Makes sense.
But that's one, and then we kind of keep an eye on like fusion opportunities of like what AI template provides, or like just fusion capabilities, right? And we make sure that those similar capabilities exist in either Torch-MLIR canonicalization or in Erie or Shark Runtime. Shark Runtime just carries temporary patches. Like we have like 25 patches or something. Over the next month, we'll try to get most of it back in. But yeah, that's typically where we start with model level optimizations. Then when we get down to first getting it on the CPU is what we usually do. It'll run slowly. Then CUDA, and then Vulkan, variations of it. The biggest challenge usually is numerical issues, where you'll just be like, oh, I tried it on Vulkan FP16 and it's a black image, or it's noise, right? And then you're walking through 120 gigabits of tensors or something like that, right? So, Vinod, you had a question?
Yeah, so actually I'm looking at this your slide here. Question I have for you is that is this what you're saying here, that right now you just got everything working, or are you getting a great performance here on Stable Diffusion?
We're doing really good performance too, and obviously we can't talk about the AMD numbers.
Sure.
They hold that, but on NVIDIA and publicly available cards, we can see really good numbers. There are I think I just have my 4090 in my setup right now, so I'll
Okay.
I'll run it if you're interested.
Yeah,
And
I don't want you to say anything you're not supposed to say, but the question I think really was that so this is based on the PyTorch version of Stable Diffusion from Hugging Face, or is the original one?
Yeah, this is the Hugging Face one, and all what we've done is in the Shark Tank repository. We try to keep it as common as possible, and in the case of F16, it requires CUDA. So the only thing we do in Torch-MLIR is we pip install Torch nightly CUDA 11.6 or something, right? So that we can get half DTEC support. And once we get half DTEC support, we can lower things down from there.
And this is all 50 inference steps for the inference part, or is it just
50, it does all 50. It does 50, including the VAE clip auto encoder. Everything is packed inside the. It all goes through MLIR and Torch-MLIR, and then like we expose the knobs for the same. Like you can see, or maybe it's not exposed in this one, but like you can pick the scheduler and all of that. So it generates the same image. If you try Hugging Face's thing and you try the Torch-MLIR version, you'll get exactly the same image with the same seed.
Great, thanks.
Any other questions on this? But yeah, we're happy to help if anyone has, and even in it doesn't have to be an engagement with Node or anything. Just like if you run into large model support, feel free to like ping us on Discord. I think our teams spent quite a bit of time tracking down tensors, and usually it's like, oh, one tensor that got truncated from like F64 to F32 and the image is black, and then oh, we promoted something from this to that, or it wasn't. So it's I think we're coming down to like a playbook of things to do when a model hits us. But soon we'll get Stable Diffusion training also up and running, and then that should. We're hoping that'll intercept with the multi-node work we're doing in Erie. So you'll have the ability to do Stable Diffusion training through Torch-MLIR on multiple devices.
Awesome. Thanks for the great work, Anush, and also just being such a good citizens of the open source community as well.
Thank you.
Yeah, so here's the list from the last month of various ops that we've implemented or improved. So we're still pushing forward on the ops port, all hundreds of PyTorch ops. And then in terms of upcoming features, besides the custom ops thing that we'll talk about in a second, so Torch Dynamo actually moved into the main PyTorch repo, which means that we are able to integrate with it packaging wise. And so we'll be, that's now planned before the end of the year. So that we should have some type of support for that coming soon. So that's the big change from last month. And then this is my obligatory slide. I ask if anybody has any feedback or kind of project health questions. Anybody have anything? Okay. Going in 3, 2, 1. Good. I've never had anybody say anything on this slide, so it means must mean that we're doing something well. Cool. Ramiro, do you want to talk about the custom ops stuff?
Yeah. So for the last month or so, I've been working on implementing the custom ops, like adding support for custom ops. We have an RFC of this posted on Torch-MLIR, but I just thought I would give a brief overview here as well for people that might not be familiar. And then we'll also look at how this would actually work for users. So the sort of core goal that we're trying to add to Torch-MLIR is to allow having custom ops without recompiling Torch-MLIR. So the idea is, so at the moment, if you register a custom op on PyTorch and then import your op into Torch-MLIR, it will import just fine. But then lowering it down requires extra information that the user needs to specify. One piece of information is the shape function of your op. So given the inputs, what is going to be the shape of the output? The same is the dtype function. What would be the dtype of the output? And optionally, we also want to allow users to specify decompositions as well without having to recompile. And so for shapes, this is already implemented. Some people who have added support for ops have had to add shape functions, and so know a little bit about how that works. But essentially, we have this Python script that turns your shape function into an MLIR snippet. And then when you're lowering down your code to the backend contract, that snippet gets imported into the MLIR, and then it gets analyzed and simplified until we have a final shape. And so for the last month, I've been adding the equivalent support for dtypes, which is almost done. I'm just like finishing up some of the final details. And yeah, I can give a demo of what that looks like now. Let me share my screen. Okay, cool. Hopefully the fonts are nice and readable. If not, I can make it larger. But yeah, so essentially what a user who wants to add custom ops to Torch-MLIR will have to do is, once they've registered their op in PyTorch, the next thing is they'll have to create a Python file where they have their shape and dtype functions for their op. In this particular case, I'm taking the add tensor op as an example. But if your op has a different name, that would be a different name. And so the dtype function, it takes the rank and dtype of the different tensor inputs. And in this case, it's a pretty straightforward. You just have to promote the dtypes of the two input tensors, and then that is the final dtype. For the function, it's also a simple broadcast function. And so this, we have special Python functions that will then generate the library. And so if I run this Python script here. It will generate a bunch of MLIR. Yeah, and so most of the MLIR here is actually for the shape function because broadcasting is tricky, but the dtype function is quite simple. So here you see a dtype function is created for a10.add.tensor. It's pretty similar to the Python code. And here in the Python code, there's also this special Python function that when imported turns into a special Torch dialect function called promote dtypes. And so then once we have this, so here I have an MLIR example of just a simple module that takes the add operation for two tensors. So if we lower this down, this is essentially the steps that take place to simplify things. Okay, so here what I'm doing is I'm just running, I'm lowering from Torch script to the Torch backend and just printing out the MLIR at important points. So first we start with, the op without a dtype. And then what's going to happen next is this reify dtype pass is going to wrap our function, Torch dtype calculate, into so it'll have two regions. The first region is going to keep track of our original op, and then the second region is going to have a call to the dtype function that we have the MLIR snippet for. And so as you can see here, that MLIR snippet gets loaded from a file while lowering, and then the next step is this gets simplified. So the simplified here we see is able to abstractly interpret that function enough so that now the dtype region only has this integer 6, which internally represents the float 32 dtype. And then this pass will, if it's able to simplify fully, will replace the dtype of our op. So now the op has a result dtype of 32, and it'll replace the dtypes of the users as well. And so the final outcome is once we drop that wrapper up, we have dtypes in the IR. And that's pretty much it. I don't know if there's any questions about that, speed run through. But yeah, the idea is you just write things in Python, and then that turns into MLIR that gets loaded while you're lowering your code.
Thanks, Ramiro. Yeah, that's really awesome. I think eventually we're going to just be able to specify this additional MLIR file to the passes, and then whatever custom op you have, you can generate the shape and dtype library functions with that, and then for what just whatever they are, and then it should just work with your custom ops that you've registered without having to recompile Torch-MLIR at all. So I'm really excited for that.
Yeah. Cool.
Were there any sort of general comments or questions about the custom op support? Yeah, Prashant?
Yeah, so the same thing can also be done for the decomposition thing, right? I mean, what we're doing right now.
Yeah, so the idea is to also allow for users to specify decomposition. So it will look basically the same as the shape and dtype function. So it'll just be a special decomposition function. And then that will create an MLIR snippet that when we load also while lowering, and we can replace your op with that. Yeah.
News, did you have something?
No, I was just going to add, this is really exciting. We are looking at different customers that have different ways of entry to custom ops. And so, obviously this is outside of Torch-MLIR itself, but we want to look at like op DSL options so that, customers could write in something like linalg op DSL or Triton-MLIR or something else, and then hook into the backend contract we have for custom ops. It's still early stages, but just something to keep in mind that the infrastructure to write custom ops is super important, because there are the lingua franca of like how you want to express those ops is another portion that depends on this landing first solidly, and then we'll build that. And that, everyone can pick their own variation of it, but there are some options that will probably come up in the next few months, etc.
Yeah, exactly. Yeah, this is just the framework. This lets us get it down to the backend contract, and then from there we, just let 1,000 flowers bloom in terms of how we want. Anything that supports MLIR pretty much can generate an MLIR snippet and feed it into the pipeline at that point. So yeah, there's a lot of exciting things we can do once this lands. Cool. Any other comments on custom ops, Suraj?
Yeah, so I just pattern matched against the prior conversation on custom ops support. Essentially trying to implement operations that are not supported by a particular dialect. Let's say Towser in this case, and the custom op thing is a great mechanism to do those. But there was also a bunch of conversation around this in the ML program dialect development. And I wonder if there's anything we need to connect together in terms of getting the stories for the ML program and this pathway together in some manner. But I haven't kept up with ML program recently.
Yeah, so I'm not up to date on what the exact set of features that are being developed in ML program, but it should work perfectly with this. So this actually is basically makes the front end part of custom ops work, and then the back end part, then we can kind of solve that independently. And so, TOSA will have its own thing, and then, like MHLO, if that has its own thing, or the Linode backend, or, you could even have just like a totally custom backend that, like generates Triton kernels or something. It could be pretty much anything. So,
Thank you.
Yeah. Anything else? All right, let's go ahead and continue then. Can everybody see my presentation still?
It's kind of small. Yeah.
Okay, let me stop sharing and then come back. All right. All right, I think it's good now. Okay, cool. A few updates from the community. So as the community's been growing, we've a lot of the review load was like getting a lot of it was landing on me, honestly. And so now we've kind of established like a more formal code owner system for the different parts of the code base, like TOSA, MHLO, the front end, the Torch dialect, Linode backend, etc. And so now we should have like a really a better set of responsibilities spread out. And so to do this, we're actually following LLVM's standard sort of code owners thing. So this little quote down here, if you want to read it, basically the idea is that the code owners sort of, they actually don't even have to review everything themselves. They just have to make sure that things are not falling through the cracks. Like that's the primary responsibility of the code owner. And then secondarily, there's also making technical decisions about what's acceptable for each component. So those two, it's a pretty lightweight system. It's not like you're like automatically going to be added onto every PR, although we could explore that. I think GitHub has a mechanism for that, but for now, I think just having a better understanding of responsibilities, I think is enough for us right now. Any questions about that? Okay, cool. Oh, Suraj. Sure, Suraj. I can add you. Let me just take a note on that. Cool. All right, yeah, let's move on then. The other thing big thing that's happened in the last month is we added a long-term roadmap for sort of where we expect the project to go in the next 1 to 2 years. Of course, plans are only plans are only plans, but I think it sort of just gives some of the big picture of where the project is going. So I'm going to just go through a few of those items here. If you want, you can read the full doc for a lot more details, but I'm just going to briefly talk about the main items here, just so everybody is on the same, just so everybody's aware. So probably the biggest item on the roadmap is aligning with some of the changes that PyTorch is making with respect to Torch Dynamo. And so this is actually what this lets us do in combination with some of the work that they've been doing on decompositions and other stuff. It basically lets us replace a big part of Torch-MLIR, this whole kind of front end part, with essentially no code. So it pretty much lets us delete that code in the fullness of time. So like I said, this is going to be maybe 1 to 2 years down the road. And so this actually is, is basically just aligning with them, giving them feedback, and making sure that the projects are aligned and synergize well. But we've already seen some really exciting, this all kind of works already in some limited cases. It's really just them rolling it out into production pretty much over the next, I think it's probably going to be at least a year total. The other big thing is refactoring our sort of the quote unquote backend. So right now, the biggest thing, we have 3 main backends that come out of the box: Linux, Tosa, and MHLO. And the problem is that they're just sort of 3 totally separate code bases, and they each have to handle these sort of on the order of hundreds or thousands. See, Anush. Hundreds or thousands of ops basically. And so essentially, that doesn't really scale super well. And so one of the things we want to do here is, the doc goes into more detail here, is somehow concentrate this bottleneck point either in something like stable HLO or MHLO here in this future A, or possibly TCP, or in future B, which can synergize with the other one. On the PyTorch side, actually, this effort they have called PrimTorch could potentially solve all this as well. And so really, again, we're sort of staying aligned, influencing the stakeholders there, and just making sure that this all materializes how in a way that just we know what options are there and adopt the one that simplifies things. Any questions on this one? All right. Yeah.
Questions really. I just want to ask if there's interest from other parties wanting to have Torch-MLIR aligned to particular major versions of PyTorch in a more production setting. For example, something like with the latest version 1.14 and 1.13 has separate forks, for example, and not just keep up with the latest nightly and potentially backput any important patches into those forks, specifically aligned to the major versions that somebody happens to be dependent upon. I do not know whether there's any kind of dependency like that from other parties. So it's possible to have a head PyTorch and a version 1.14 and a version 1.13 supported one, but that's only if there are multiple people interested in that.
Yeah, I'm not hearing anybody in this call, but sort of informally in other settings, this is definitely a real need. And as Torch-MLIR is more mature, I think we definitely do need this. It's just a matter of when. Shivash?
Yeah. So question mainly related to the previous slide and maybe the future B option here. By moving the decompositions and checkpoints and etc. to Torch, how does that what does that entail in terms of the Torch-MLIR users' capability for doing selective decompositions or custom op support and etc.
I think you were breaking up a little bit at the end, but you're asking essentially how users will control decompositions.
Yes, yeah.
Yeah, so I think this is something that is a requirement that we're feeding back to the PrimTorch folks essentially for how this is all going to be controlled. So they're very aware of the need to control this, and I believe they already have mechanisms to do it. Like, I don't know if it's the exact way things will eventually work out, but for example, when you use some of the FuncTorch tools already, you basically pass in the list of decompositions you want or don't want. And so you just have complete control, basically.
Great. Thanks for explaining.
Cool. Let's go on then. One of the other items on the long-term roadmap is for what I'll call like advanced ahead-of-time compiled deployments. So really the biggest question here is how to package like model state and potentially control flow and non-tensor computations into like a single compiled artifact and the backend. So some backends like don't support this. They sort of just assume you're running in process with the framework. But then other backends actually do have the ability to just like produce like a standalone binary file or something, which is like, okay, here's your like ARM binary that can run your thing on a phone or on a microcontroller or whatever it is. And so for those backends, we need to find a way to like really figure out how to combine the sort of like purely functional tensor computation with all the model state and stuff. And so this is something, again, we're aligning really closely with PyTorch on this. And I think they're still sort of digesting what's the best way to approach this. But I think the one thing that's really clear, though, is that so the first bullet here is that we're aligning with what PyTorch is currently doing in terms of kind of purely functional graphs, like that sort of what they currently do with tracing and Torch Dynamo and those sorts of things. So we're aligning really closely with that, and we know that whatever they're building is going to be built on top of that type of abstraction. So whatever types of thing they kind of put around that, we'll be in a really good position then because of that alignment to then sort of just build out whatever is needed to capture the new features that they are adding and then build them on top of the existing features that we already support. So that's expected to work out really well. It's just a matter of waiting for more of this to materialize or get more clarity on the roadmap on the PyTorch side. The other long-term roadmap item is related to project governance and structure, and the sort of TLDR here that we probably want to move into PyTorch for a few reasons. Really, maybe the one to call out most here, since actually this already came up in the call today, is integration with the PyTorch CI systems and packaging. And those sorts of things. So that's expected to be a really big benefit of aligning more with PyTorch. So I think being part of the LLVM incubator has worked really well, but like these days we actually don't really do a lot of synergy or like synergistic design work with LLVM. Most of what we're doing there is on the PyTorch side. And I think that's likely to continue to be the case because really things on the MLIR side are, I want to word this carefully, but in a sense, they're stabilizing more. And so I think generally PyTorch is going to be the kind of the moving target that we're really shaping our plans around in sort of the 1 to 2 year time frame. Yeah, actually, so that's the end of the long-term roadmap section. Are there any questions on that, Suraj?
Yeah, sorry to be that guy again. I see that you mentioned PyTorch and MLIR. What about Annex?
So the
Major
alignment.
version of that, for example, the upset and touch version.
So what's exactly your question?
I mean, does Torch-MLIR, the long-term intent to also explicitly recognize its alignment to versions of Onyx upsets in any manner? Or do we want to consider that?
So right now there's no explicit alignment with Onyx. So there's work being done to lower Onyx into Torch-MLIR's backend contract, because then we can reuse the MHLO, TOSA, and Linalg lowerings. And so there's kind of independent work there, but that work takes Torch-MLIR as a dependency. So from Torch-MLIR's perspective, it's sort of like a no-op. It's not like we support, how should I say this? It's not that like we are calling into Onyx. It's like really them calling into our API, and our API is essentially the PyTorch offset.
I saw that. You probably also know the added dependency that there's an individual piece from Onyx to TOSA as well. So there's like two independent.
Yeah,
That's
yeah. I think
we're not going into that now. I think
that's a little bit of a I don't know. That's complicated. There's also a direct Onyx to MHLO path, but I think it sounded like there were a lot of folks. Yeah, it sounded like there were a lot of folks in the community interested in this path as well, and so let 1,000 flowers bloom, I guess, such as open source. Any other questions on the roadmap? All right, let's move on. Actually, Anush had to go, and I don't think Ashay is here. Yeah, Ashay isn't here. So I'll go ahead and give just essentially read the slides here. And so essentially, Ashay and Anush have been doing some really good work in terms of getting the builds cached, both the PyTorch, especially the PyTorch dependency, and this is going to like really speed things up and avoid these like, oh, it took like an hour to do the pre-submit tests type thing. So that should be great. And a bunch of infra work has gone into that. And so, I think this is going to really make things way better. Any questions on this slide? Cool. Yeah. So that's the end of the presentation. We are free to. We have about 20 minutes left, and we're free to talk about if anybody has any Q&A for the presentation or discussion of any topics, or if you'd just like to introduce yourself. I'll go ahead and open the floor now. All right, well, if there's nothing else, then I think we can end early and get our 20 minutes back. So thanks everyone for joining.